today to show how to square off the corners of a mortise using a CNC router to allow you to put a square tenon into a mortise. So I had a customer that emailed me for a quick refresher on how to do this. And basically, he makes rustic furniture out of 2x material. And so I don't know what size tenon he's using. I just created this one. This is an 1.5 by 1/2 inch and a 1 inch deep tenon. So this is basically what I'm going to show you to use for this example. So we're going to come into VCarve, and I've put down a piece that's 12 by 3.5 and 1.5 inches thick. That's great. I'm going to do a rectangle that's 1.5 inches wide by 0.5 tall or in height. I do them to match, and then I do a tool allowance to give you extra slop to be able to fit the tenon into the mortise. To me, this makes better sense. Some people would rather do add a 32nd to these sizes or a 16th for glue and slop. It doesn't matter. It's whichever way works better for you. But I'm going to create that rectangle. Now, what we have to remember is that if we're cutting with a router, we're using a round bit. So I'm going to do a 1/4 inch cutter. And so there's my cutter. Now, if my cutter were being used to cut this mortise, it's going to cut along this way, get to here, and start coming down. But what it will do is leave this area right here rounded off. So you can't put a square tenon into a mortise that has this amount of material in all 4 corners. So VCarve has a way of dealing with this. There is a gadget you can use that will do this automatically. I tend to do it this way, though. I come to the filleting tool, and let's review what the filleting does. I'm going to set this up to use this same tool, a 1/4 inch cutter, which has an 1/8 inch radius. So typically what this would do on a normal fillet, if you touch the corner, it would radius that out. And so this is the area that we're going to have material that we need gone if we're going to have squared off tenons. So the option there, if we touch it again, it'll take the fillet away. There's 2 different other options here, a dog bone and a T-bone fillet. Both of them have their place. If we do a dog bone fillet using the same size tool, and I tap there, I would be able to get my squared off tenon into this because it will fit. And there's also, if I come back to it, there's also a T-bone fillet, which I'll use here. And you'll see that they're very different they're going to give you the same finished output. I'm going to delete this to get it out of the way. But there's 2 different finished effects. So this would give this gives a nice straight edge, and then just for grins using a 1/4 inch tool, it's about a 40,000th part right here that you're going to see. So I'm going to zoom in. I'm going to grab the high end and come down here. 0.0367, so roughly 40 thousandths is going to be showing if I did a full tenon or I was fully inserting a part. If I'm using this type of setup, that's going to be overcutting in this area by 40 thousandths in a radius, in a part of an arc. That's okay. I'm not going to see any of it. It'll allow glue squeeze out. Everything's good. If I do it this way with the T-bone fillet, I'll have a lot more area to glue on the 1/2 inch part of the tenon as opposed to here. But I'm going to have a bigger hole cut that could be visual. You'll see some box demos done with, basically someone did a box joint, and they left them showing like this. Well, I would do them like this, and they don't show up as much. But this is why I like to be able to look at it, because in either case, this will work great because he's doing a tenon that's going to have significant shoulders to it. That's going to cover either of these. But that's how you do it. So this allows the router bit to come down. It'll jog around and come over here, jog around and come back up. And if we're looking at this will be back to the size that we wanted for the 1.5 inch by 1/2 inch. So to tool path it, we're going to flip over to the tool pathing side of things. I'm going to select the geometry that I want to work with. I am going to select a pocket operation, 1 inch depth of cut, 1/4 inch tool. I don't need a larger tool. I'm just going to do it in one tool. Just let it take its time. And go ahead, and this will be pocket, dog bone, and T-bone. And we'll reset the preview all, And there we are. So this shows you the two different ways that we have for being able to put a square tenon into a router cut mortise. Okay, I apologize. I had an appointment come in and didn't get to finish the very last bit. So to do the tooling allowance, we wanted to overcut the size of the, okay, this was going to be, I think it was 1.5 by 0.5. But we want to overcut that to give us room to allow the mortise to fit in. So I'm going to do a T-bone. I think I had those on this side. I mean, a dog bone over there. I'll do a T-bone here, still using, I hope, the same tools. And then I'm going to go into the tooling. And this is where we're going to do a pocket. I'm going to select the geometry that I want to do the pocket on, still with, I think we had called for a 1-inch depth. I really don't care. It's not pertinent to this section of the video. X number of passes, okay. But this is what we're going to look at for, is this tooling allowance. So what I usually do is, until you get the hang of it, you want to see what that's going to do. So I'm going to do a 0.125 tooling allowance, or I'm going to say even smaller than that, 0.0, say 5. So 50 thousandths tooling allowance, pocket allowance. And let's see what that does. I know what it's going to do, so it's not a big deal. You'll cut through the material, because I've got this material now at 3/4 of an inch. I'm just going to let it go. I don't care. But if you look at what it does, is it took the geometry line that we were working with and pulled back 50 thousandths. So let's look at that again by double-clicking on that tool operation. If I go the other way, what does that do? If I go a negative 50 thousandths and recalculate it, what does that do? Well, now it's overcutting. That's what we want to do. So we want to play with that value right here, whether it's 20 thousandths, 25 thousandths, 30 thousandths. You're going to have your own preferences based on what materials you're using and how much glue you're using, how thick the glue is, blah, 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 blah. So this keeps it very easy for you to modify this based on the products that you are making. So we're going to leave it at 50 thousandths for now and tell it to calculate, update it, and we're through it. So that pocket tool allowance right here was what we wanted to look at, to overcut the geometry. So I can make this geometry be the same size as the tenon so that the numbers match. So when I'm thinking about it, that's this size tenon, it's that size mortise. But I need to overcut the mortise by this value right here. So very cool, very easy. Vectric did a wonderful job of implementing this to make it simple, and that's certainly appreciated. So if you have any questions, I'm happy to help you. Go to YetiSmartBench.com, go to the contact page, fill that in. I do the bulk of the sales and the training for anyone in the U.S., and I'm happy to help you in any way that I can. Thanks so much.